I'm a big fan of these sorts of questions. So quadratic to the power of, oh, in this case, a quintic is equal to 1. But it's not as bad as it seems. The things to think about are as follows, all right? Any number that's non-zero to the power of 0 is equal to 1. So we can look at x to the 5 minus 5x cubed plus 4x equaling 0. And we'll do that in a minute. We can also think about 1 to the power of any number equaling 1. So in a minute, we can look at x squared minus 8x plus 15 is equal to 1. And there's one other that's quite easy to miss. Minus 1 to the power of an even number is also equal to 1. So in a minute, I can look at x squared minus 8x plus 15 equaling minus 1. Right, which one to start with? I'm actually going to do it in reverse order, I think. The quintic looks the most complicated. So this here gives me x squared minus 8x plus 16 is equal to 0. And actually, if I factorize that, I get x minus 4 squared equals 0 and x equals 4. I get one solution. I just need to check that that gives me an even number up here. And I'm going to get an even number minus an even number plus an even number. It's clearly going to work. It checks out. So we get one solution. If I got an odd number, or I don't know, I'm not going to get a fraction, am I? But yeah, if I had an odd number, then it wouldn't work because I'd get minus 1. Minus 1 to the power of 3 is minus 1. Right, next up, I'm going to take a look at this one. I've got a bit of space here, so it's going to be x squared minus 8x plus 14 is equal to 0. Now this doesn't factorize easily, and all I'm really interested in is the number of real solutions. It's not going to matter. I've got what I have in the power. So I'm going to complete the square. It's going to be x minus 4 squared minus 16 plus 14 is equal to 0. So x minus 4 squared is going to equal 2. And that's enough to see there's going to be two distinct solutions. I suppose we need to check that they're not the same as some of the other ones. So maybe I should find them. It's going to be x minus 4 is going to be plus or minus the square root of 2, and I can add 4 to it. So I'm going to get these two. Two distinct solutions, and then another one here. Right, that just leaves us with this quintic. Okay, well, there's a common factor of x, so the first thing to do is get rid of that. X to the 4 minus 5x squared plus 4. And actually, we have a hidden quadratic here. This is just a quadratic in x squared. So let's try and factorize it in x squared. You can do a substitution y equals x squared if you want, but I'm just going to go straight for it and factorize x squared, and then just do it in exactly the same way that you would for a normal quadratic. Two numbers that multiply to give 4, but add to give minus 5. It's got to be minus 1 and minus 4. So x is going to equal 0, or x squared is going to equal 1, which is going to give me plus or minus 1, or x squared is going to equal 4, which is going to give me plus or minus 2. So from this, I get 5 more solutions. And so in total, it's going to be 8. How many different real number solutions? 0, 0, 8. Neat.